All right, so 10G is all about dependent events. So yesterday was all independent, where everything is independent of each other. You've got most of this on your note sheet. This is the only piece you should add at the bottom. Basically, if you do not replace something, think about we talked about the hat. If you draw something out of a hat, if you replace the ticket or the item, whatever you're talking about, it will be dependent. If you do replace it each time, then it's going to be independent. So this is the piece you should add onto your note sheets. All right, so for example, here's our ticket. We have a box with 4 red tickets and 2 yellow tickets. So our total in our box, we have 6 tickets total. So we want to figure out what's the probability that they are both red. All right, so probability, let's just say 2 red. Okay. So what's the probability the very first ticket will be red? Is 4 out of 6. Then we just end up multiplying the next ticket. Now let's think about this. If we take 1 red out of our total, we are left with 3 tickets that are red, but we only have 5 tickets left. So this is the first ticket taken out, 4 out of 6, times the second ticket taken out. And since 1 red ticket was taken out, we have to take 1 out of both of them. And we just multiply. 12 out of 30 is reduced by 6 to get 2/5. All right. But the key is without replacement. All right. So for letter B, probability of red, then yellow. So if the first one is red, we're still having our 4 out of 6. Then the second one is yellow. We still have 2 yellow tickets in. Oops, that was 6, right? So there's 2 yellow still left in the bag, but we only have 5 tickets left. So you just want to figure out each one individually and then multiply them together. So 8 out of 30 or 4 out of 15. All right. So now a hat contains 20 tickets. So our total, 20 tickets total. If 3 tickets are drawn without replacement, so that means dependent, determine the probability that they are all prime. All right, so first we have to figure out of the first 20 numbers, what is a prime number? So 2 is our very first prime number. You never start with 1, you always start with 2. 2, 3, 4 is not, 5, 6 is not, 7, 8 is not, 9 is not, 10, 11, 13, 17. All right, so there's 1, 2, 3, 4, 5, 6, 7, 8 prime numbers. All right, so, and what are the notations? Sometimes you see the letter N, it just means the number of prime would be 8. So just understanding that notation is important. All right, so what's the probability 3 prime total? So think about if we take 1 ticket out, what's the probability the first one is prime? Is 8 out of 20. Now 1 prime ticket is out of the hat. In order to get 3 prime total, They all need to be primed. So the first one prime is out. Now I'm down to 7 out of 19 for the second, times the third. Now 2 prime are out, so I'm down to 6 out of 18. And if we multiply all of these, I'm going to give you a decimal. 3 sig figs as my final answer. So it's not really necessary to get multiply and get you an ugly fraction. You can just use a decimal for this one. All right, so here's our flower box. This one starts out a little bit different. We actually have 2 flower boxes, each containing purple and white flowers. All right, so box A contains, here, let's go here. A has 2 purple and 4 white, and box B has 5 purple and 1 white. So we first select which box we're going to pick by tossing a coin. All right, so we have to first determine, so we're going to make a tree diagram, which box we're going to pick from. Box A or box B. So the probability that we take from A or B, we find by flipping a coin. So flipping a coin is 1 out of 2. Okay, and then from box A, we're going to pick the flowers. So it's either purple or white from each box. All right, so for box A, purple is 2 out of 6. So we'll say 1/3. White is 4 out of 6. So that's 2/3. In box B, we have 6 also. Purple is 5 out of 6, and white is 1 out of 6. Now we could have kept it 2 out of 6 and 4 out of 6 up top here, but the numbers will work a little nicer if we simplify. So everything, we've got our pathways all established. Now, what's the probability of A, box A, white? So if we follow our pathway, A, white is 1/2 times 2/3. I just like to cross cancel when we multiply to get 1/3. For letter B, probability of purple. All right, so we've got a couple of different ways to get purple. Let me change my highlighter here. So I can either pick A and do purple this way, or we can go B and purple this way. So anytime we have multiple steps, we're going to follow each pathway and just add them together. So box A, purple, is 1/2 times 1/3, plus box B, purple, is 1/2 times 5/6. Now we just multiply our fractions. 1/2 times 1/3 is 1/6. 1/2 times 5/6 is 5/12. So get a common denominator. 1/6 is 2/12. Plus 5/12 is 7/12 total. All right, last example, example 20. We've got 10 balls, so our total is 10. 6 are black, 4 are white. 3 balls are drawn without without replacement, so that means it's dependent. But here's the tricky thing. It doesn't say the order in which they are drawn. So think about if we've got black and white balls and we do 3 balls. We can either draw what's the probability exactly 1. If it doesn't say it any different, that 1 black ball is drawn is exactly 1. So it means the first one could be black and the second 2 are white. Could mean the first one is white, the second one is black, and the last one is white. Or the first 2 are white and the last one is black. So those are all the different combinations we could have. All right, so probability of 1 black equals. So if you think about this, we can either just find the probability of each one and then take it times 3, or we can show it all 3 ways. You've got a couple of choices. Let me show you all 3 ways and then how that could work. All right, so first of all, the probability of black is 10, or 6 out of 10, times white. 1 black one is gone, but I still have 4 white, but only 9 balls left. And the next one is white, so we have 1 black and 1 white gone, so I'm down to 3 white out of 8 total. All right, plus, so this is this combination. Now, do you see as we do this, if I take this second situation here, the first one is white, I'm just taking all 3 of these and rearranging it. I put the 1, this would be 4 tenths times 6 ninths for the black times the white is 3 eighths. This ends up being exactly the same value. Plus, first one is white, 4/10. Second one is white, 3 ninths. And the last one is black, 6 eighths. So technically we could just find the probability of 1 and take it then times 3 at the end. So let's look at what this would be. I'm going to go ahead and just cross cancel here. 3 can go into 9 3 times. 4 can go into 8 2 times. We can reduce 6 tenths into 3 fifths. And then the 3's can cancel. So this really is just 1/10. All 3 of these. 1/10, 1/10. So my final probability should be 3/10. Now you can just multiply and get your big numbers. I just would rather deal with the smaller ones because I think it's a little less, busy. But like I was saying earlier, you can either find the probability of just black, white, white and take it times 3 because they're all 3 the same, or you can set up each individual case.